Welcome, my dear student. I am A. Venkatesan, Assistant Professor, Department of Mathematics, St. Joseph College of Arts and Science, Autonomous, Kadalur. In this video, we are going to see complex number. In complex number, modulus of complex number, triangular inequality of complex number, and regions in the complex number. What is modulus of complex number? Let Z be any complex number like Z equal to x plus iy. Then the modulus of complex number is defined by mod Z. That mod Z equal to the square root of real part square plus the imaginary part square. The last video we know how to find the moduli. What is the moduli? It is the distance from the point to the origin or the origin to the particular point. So that's only we are using here the square root of x minus 0 the whole square plus y minus 0 the whole square, that is 0 is mentioned by the origin. Similarly, if mod z1 is less than mod z2 means that z1 is closer to the origin z2. For example, let z1 equal to minus 3 plus 2i and z2 equal to 1 plus 4i be any two complex number. We take mod z, that is mod z1 equal to square root of real part square plus imaginary part square, that is minus 3 the whole square plus 2 square, so that is equal to square root of 13. Similarly, mod z2 equal to square root of 17. So it's clear that the square root of 13 is strictly less than square root of 17. So therefore we conclude that minus 3 plus 2i is closer to the origin 1 plus 4i. The next, triangular inequality. What is a triangular inequality? Modulus of sum of two complex number is always less than or equal to sum of the moduli. So that is mod z1 plus z2 less than or equal to mod z1 plus mod z2. So now we are going to prove the inequality. So we consider mod z1 plus z2 the whole square, because we know mod z square equal to z into z conjugate. So we choose mod z1 plus z2 the whole square. So that is we write z1 plus z2 into z1 plus z2 conjugate. And the next step, so we take conjugate of the second part, that is z1 conjugate plus z2 conjugate. So we multiply these two, so we get z1 into z1 conjugate plus z1 into z2 conjugate plus z2 into z1 conjugate plus z2 into z2 conjugate. Now we apply the same result, z into z conjugate equal to mod z square. So therefore the first one is mod z1 square plus z1 z2 conjugate we keep as it is, and the third one is we rearrange by our convenient z1 into z2 conjugate the whole conjugate, because z conjugate the whole conjugate again is z, so therefore it again z2 and z1 conjugate, and fourth one is z2 into z2 conjugate is mod z to the whole square. So next one, we keep the first and last term as it is. The second term is, what is the second term? Z into z2 conjugate. Third term is z1 into z2 conjugate. So it looks like a z plus z conjugate, that is a complex number add with the conjugate of the complex number. So we know z plus z conjugate equal to 2 times the real part of the z, because we know conjugate means the sign will be changed in the imaginary part. So if you are adding that, it will be cancelled, only we get the real part. So therefore we can write the second one is 2 times real part of z1 into z2 conjugate. We know the real part of z is less than or equal to modulus of real part of z. It is less than or equal to again mod z. So therefore the second step replaced as second term is 2 times mod z1 into z2 conjugate. So we keep the first and last term as it is. And the second term twice into mod z1 z2 conjugate is mod z1 into mod z2 conjugate. And also we know that conjugate of mod z is equal to the mod z. So therefore we can write mod z1 square plus twice into mod z1 mod z2 plus mod z2 the whole square. So it looks like a plus b whole square form. So therefore we can write mod z1 plus mod z2 the whole square. So taking square root on both sides, so we can get mod z1 plus mod z2 strictly greater than or equal to mod z1 plus z2, that is mod z1 plus z2 less than or equal to mod z1 plus mod z2. So we want the result for suppose in mod z1 minus z2 the whole modulus, it is also we can prove. So that is in this triangle inequality replaced z2 by mod z minus z2, and after simplification we will get the result for mod z1 minus z2 strictly greater than or equal to mod z1 minus z2. So using this triangle inequality, now we can generalize to this cases. So what is a generalized case for triangle inequality? So the modulus of sum of complex number less than or equal to sum of the moduli. So the last one, just we take only two complex number. So now we take more complex number. So again we prove this result by using method of induction. So our initial case we put n equal to 2, just to put n equal to 2 means mod z1 plus z2. So that is already we are having the result, the last result, triangle inequality. Mod z1 plus z2 is less than or equal to mod z1 plus mod z2. So we assume that the result is true for n equal to k. So now going to prove what is the result for n equal to k plus 1. So now we take the modulus of z1 plus z2 plus etc. zk plus zk plus 1 by our convenient and also by the result. So it can be split into two, that is z1 to zk as one term and zk will be considered the next term, because we know a result only for k. That is, we proved up to k it will be satisfied. So therefore again it will be considered as z1 plus z2 z3 etc. zk as a single term and zk plus 1 is the next term. So again by the triangle inequality it will be less than or equal to mod z1 plus z2 z3 etc. zk plus mod zk plus 1. So already we know what is the result for modulus of z1 to zk value, that is a statement is true for k value. So that is we write mod z1 plus mod z2 etc. mod zk plus mod zk plus 1. So therefore we will conclude that mod z1 plus z2 plus z3 plus etc. zn less than or equal to mod z1 plus mod z2 plus etc. mod zn.